All right, good evening, everyone, and welcome to the part 3 of the Printf series. Uh, I hope to cover much more today or in this very section as we work together. You know how you roll, so I'm going to get my terminal up. I like using two, one for my editor and one for the terminal. One to run the codes. Okay, so I have to be in the same location. Yes, that. Yes, software engineering. This is the B. I no. Can be. Excuse me. I push this stuff to Git, and this is after the repo. Okay, up to date. Okay, that's the C printf. CD into C printf. So part 2, that directory part 2 is where I save what we did in the part 2, the codes we wrote there. So I will just move away from here and copy recursively what I have in that directory part 2 into another directory. Would this command create a directory automatically? It should. This is copy. It should. So I'll call this part 3. So it worked. I now have part 3 here. Part 3 has a copy of everything we did in part 2. I just want part 2 to be untouched so that anyone that sees the video and wants the code can access the code, can access them and the video way they were at the end of that session. So every modification I'm going to do will be inside this other directory, part 3. Okay. I have to be in the same location here. I think I want to rename this directory to something shorter. Excuse me. I'm sure denied. Well, I'm not the one that created it. I don't get time Windows. So I have to be in the same location. All right. So now I'm going to call for my Emacs. Let's see again what we have in. That's what we have in all the files. I'll begin from put car. No, I don't need to open put car again. You can start in the other video. I'll begin from printf. Okay, so in printf.c, this is what we have. Yeah, we have, and we were able to implement. We were able to make our printf not to print this guy. So this create character special. Then we're able to 15 that it should check what follows that guy. If it is character, it will now go to the next guy member of the list. Assuming that it must, or presuming that it must be the variable or the character. Take that again. Presuming that it must be the character or the variable containing the character. Yeah. And then wanted to implement string. So I will continue from here. Let's implement string. So what I'll do is this. I'll comment this and take off to be continued because it is now continued. So else, if what follows percentage s, so sorry, if what follows percentage symbol is s, this is what I want you to do. And we can't use put guy again because Now watch this. I think I want to create another file here, another .c file. I'll call it test.c. No, something else. Okay, test.c is fine. It means I have to have the executable file named after the file that it's presenting. So let's have mem.exe rather. Yeah, so that with this test.exe. Okay, yeah, that's it. So if I make a file called test.c, it will be obvious that the executable test.exe is from test.c. Okay. What I want to do in test.c is this. I don't want to start over, so let me copy what I have inside main.c into test.c. And I'll go here and now open test.c and edit it. What was I trying to do? I was trying to show you, remind you how that what Putka can does. See grammar now. What Putka can do and what Putka does. So I want to take this off. I don't have only the string as my name, so I can actually use Putka to print what is inside that string. How do I do that? It's by using a for loop or a loop rather. And I choose to use the for loop here. So for no, you know that normally Putka can, okay, we did that in former video. Putka can print if I say print um, a particular index of the string name, Putka will do that, But then we wanted to print all of it, so I say for int let's say int p equals 0, as long as int p is less than, let me class we have here 1 2 3 4 5 6 7 8 9 as we speak. Red plus top man 11 12 13 14 15 16. So as long as this guy is less than or equal to 16, that's less than 16, so should be actually keep incrementing the variable p, and as you keep incrementing it, what you're going to be doing each time you return true is to print whatever is at the particular index that has the value of p at the moment in time. Okay, we are good. And after this, of course, you want to put a new line. Okay, so I just did this to illustrate how Putka, one thing about Putka, how Putka can actually print a string. So let's have it done. So GCC test to see and name the executable as test. No, test. It compile with that error, which we have it there right now. Text.exe, the clear my screen, and I'm going to run the executable. Then he printed it. So we did not use printf, we did not use put, we used putcar. By the way, let me show you something about put as well. Put, let me use put now and let me use put somewhere here. I'll show you something about put. Put does not respect this percentage. That percentage is not respected here. So let's say put percentage d, percentage d, comma, percentage c, comma, percentage whatever. Somebody should give me one now. Let me pretend like I'm blank. Percentage what?
Don't disappear. Don't worry, appear at any time. Let's start it now. So let's
Yes. Okay. Thank you. Okay. So if I do this now, put, let's see what put will do. Put actually puts a string to the standard output and print a new line. Okay, so it compiled that error. Run it again. You printed percentage D, percentage C, but I couldn't do that to print F. You couldn't do that. No. How dare you? How dare you do that to print F? Yeah. This still us try to understand how these guys, how these things work because you need the understanding. Printf, the project Printf incorporates uh, your understanding of or your knowledge of everything you've learned, almost everything you've learned, almost everything. Even those times you used to write these functions, use putcar to run. When they make, you're asking yourself, why am I using putcar? You know, Printf can do this, and so why am I using putcar? This is one of the why. This is one of the why that I ask you to implement a printf function, a bullet printf function. By the way, I'm talking like I'm addressing alien students. So if you're seeing this video and you're not an alien student, just follow. Don't mind me. But alien students happen to be my primary audience. Okay. Um, so um, I meant to say that everything they ask you to do is for a reason, not just to stress you, not just to suffer you. Of course, there are hard things in a way. Yeah, there are hard things. I like using the word in a way. There are hard things, but I when you figure them out, the subject is just look it suddenly looks simple. Suddenly just looks simple, but it could use some certain understanding. So I'm going to be recalling. I'm going to be making reference to certain things that we've learned in the past, certain functions that you've written in the past. Uh, I guess we'll be doing that. So printf. Let's try to see whether we can send this to printf. I copied that, right? Yeah, I copied it. Let me change this to printf. Printf. And of course, since it's printf, it will not add any new line for you. You add by yourself. So let's even see whether this thing will agree to compile. It's compiled. Woo! Okay. Somebody said, what are we expecting? What will happen here now? Let's think like the compiler. What will happen here?
Printf will expect arguments.
Okay. But it has compiled, so printf cannot complain at this point. Printf has to give us something. It has compiled. If it didn't compile, then we should have had the warning that printf is a certain argument. Now it has compiled. Printf will expect argument, but will not see the argument. What will it then do? Let's just talk. That is kind of being wrong. This is me um, stirring your curiosity. What do you think will happen if we run this program? If you don't talk, I won't run it too. I'll just skip it and start doing something else. Somebody should talk. What will happen? What will percentage D put? What is percentage C put? What will percentage S put? All right, find out. Find out. So I meant to say that you couldn't, this thing will not give us percentage D. Of course, it will not. So if you wanted to print percentage D, you have to add percentage D and put double percentage sign. You know, and it is one of the things you're going to be implementing in this video, hopefully. How that um, if you want to print percentage sign in the standard output in printf, make it double, right? So one will be the extraordinary one, the one that is not ordinary, and then the other one will be the ordinary one. And we're going to implement that in our code as well, right? So look, watch what I'm doing in 15. We're going to implement it in our own printf, and watch what I did between line 8 and line 11. We're going to need that to be able to iterate through the member. Okay, let me show you. To be able to iterate through this stuff, let me go back to our test file, main.py. C. Okay, it's not here. Should be printf. C. Oh, my printf. Okay. Now that we are saying that if it's S, that means what is going to be there? The next member of this guy, this this ellipse, the next member that will be there, the argument that we'll be expecting should have string, an array of character. To iterate through them, we need to do something similar to what we did in this place. Guys, again, test and see what we did between 8 and and 11. And it would be nice we do it in a separate file, in separate function, so that we don't have any particular function too crowded, any particular line of code too crowded, and we don't have to repeat. I mean, we can always reuse it. Okay, and so now let me run this code. All right, so it prints. Now the puts is printing its own. First of all, put guy is printing this, right? Then put is printing this without us doing anything special. Everything was ordinary to it. And then printf is printing this just because we made a percentage to put 2. All right. So let's go ahead and implement our own. Okay. So I'm going to declare another function. I will name it, let's say after my, where's that guy? I have a function by the name picture, right?
Anyhow,
What's the secret behind using the double
What's the secret behind?
that
We are in
printf line?
we are in the part 2. We are in the previous section.
I think you're doing that code.
Are you there? I think that was explained there. See the video. We have said that when you see one, when you meet any, can look at our code again. Look at our code. We have said that we have said iterate through what you have in this string. I mean this string here format. There's a string which is the first argument of printf, and there are there's a variable number of arguments rather, and then they're saying that go iterate through the string what you have between the double quotes in printf. As I'm iterating through it, if any member of the index, if any element at any index is not percentage, then print it out. This is our own put car that we define ourselves. Print it out. That means if we've indirectly said if it's this thing, don't print it out. Don't even count it, because we're returning integer. Don't even count it, don't print it out. So how then will someone print percentage? Is by giving another instruction that, we are saying that if C is what follows, print character. If S is what follows, print string. So we now say that if percentage is what follows percentage, we are checking for h plus 1 right now. If percentage is what follows, then print out the percentage. So that's why we need to use double, and that's how the original the standard library printf works as well. So we are emulating it, right? So I want to have another file. I will call this one put string. Please, somebody should help. I hope there is no file with this name. Put str. Is there any standard library function with this name? Put str. I hope there's none. Put. Okay, let's do it like this. Put underscore s. I'm sure there's no one like this. So put underscore s dot c. I'm going to copy, because of speed. I want to copy what I have in our output char into this put. Hey, I thought I have a new file. Okay, it's not saved yet. So into put underscore s. All right, and then I'm gonna open to see what we have there. Yes. Okay, so we are still including header.h, and I'll call this a returns int. Yeah, returns int, and then the name is now put underscore s, and then its argument is a string, takes a string as an argument. So as nobody's forcing me to use any prototype. I'm free to use my prototype. And then what it should do for us is to use our own putka and say, let's iterate to the number by declaring a variable that we use to iterate through it. Say int elements or int index. Let me call it idx. Okay. So we use a for loop, something similar to what I just did with underscore with putka, with the standard library putka for index equals 0. As long as index is not do I even the while loop work? I think I'll do the while loop. While string while any particular index of a string is not the null value or the null byte. Keep doing this, and here I need to initialize this kind 0, and I need to still specify that there should be this guy. So if the string exists, go ahead and carry out this instruction. Okay. So what I want you to do now is to I'm using my own butcher. String idx. Okay. And as I do this, I need to count. Right? I need to take count. So let's do. Let me do this. Let me have another guy. I call it arrow value.
It is not the condition of while. It is not different to the \0.
What? Come again.
In the while condition.
Yes.
While string is different. The not equal.
Thank you so much. Is this what you mean? Is that what you mean?
Yes.
Thank you.
Welcome.
So our value plus equals 1, and that means our value is initialize here. Okay. So it prints a count 1, and then until it hits the null byte, then what it does is it will break out of the loop and we are done. And then you need to have a return value. You're returning int, and what you are returning is the count. So I'll call this our value, our val. Yeah, good. If there is no trouble in this code, it should compile. Meanwhile, I need to have this prototype inside my header file, which is header.h. And so I'll add it here. And I'll add a semicolon. Okay, so let's compile. Right now, I can't use the white cat again. It's because of this test of a man that I just used. Maybe I should make a different directory for it. Test, yeah. And then move test.c and test what? Test.exe. So the directory test. Great. So this gives me the freedom to use the white card. So GCC every.c5 and give me the output main, which of course will be main.exe. It's okay, it's enough. All right, here we go. Wow, we compiled that error. That means we are ready. So I'll go back to the my printf function and now give the condition that as long as it is s that follows the percentage sign, use this function. Use this function on what? On what? What are we using the function on? Now we want to use the function on the next member of the list, which we believe will be either a string or a variable containing a string. To access the next member of the list, your common knowledge of VERDICT function, has it that this guy var arg is a pointer to the next member of the list. So it should give us access to the next member of the list. And this time I think we should state that the next member of the list is a pointer to a character or a string. Let's see whether this will work well. And then of course we have r value here, okay, to break out and count. So this is, we don't need to increment it here.
Missing close parentheses.
Thank you so much. What's your name, please?
Hajar.
Hazard. Oh, the same Hazard from the welcome. Thank you so much. I'm glad to have you. You're such a huge support. All right. It's like bugs don't pass through your eye. Your eyes are your eyes are natural debuggers. Okay. So let's run this again. Let's see what happens. No error. Now let's go and test our file with main.c file. Now this is basically, for LS students that are watching this now or that in this section, this is basically what your checker does. It is programmed to have test files, to see whether our codes are working as expected. And that's why they give all of us prototypes, because the checker can be coming to check what your return value is, what this, it just expects you to return a particular, that everybody in the whole area working on that project should return the same type of value, should have the same name, because I don't know exactly how it works. I don't know exactly what it is that is there, but I believe that it has something that looks like this kind of, maybe not this kind of command now, just see white cat. It will ask for those names, those particular names, and it has include main.h in its test file as well. That's why it is okay to rename your header file to whatever you want, but in LAX you must give it the name that they've asked you to give it, because that's the name that the checker has. So it comes to check for your code, and it has what word should I use now? It has edge cases, something like extreme cases. Your code might be working well, they will not go and test some hard points where you may not have paid attention to. I think I may review of those things as we make progress. So we are testing our code by ourselves. So let's test now whether this code will be able to, we put in printf. I want printf to do what my printf to do what printf is doing. Okay. So right now, so C man is a man. Let's do percentage S is C man. Okay, percentage S is a man. So this is supposed to print, percentage S is supposed to print the content of the variable name, and percentage C is supposed to print the content of the variable later. So that will give us top man Paul DK is a man, if this works well. So let's do the same thing to our function. Let's see whether it's working like the reprint F. So percentage S is percentage C man name, comma later. Okay, so our return value is still there. Let's see whether the return value will give us the same thing as well. If anything is wrong, we'll fix it. Now let's compile again. Great. Let's run our code. Ready? Fingers crossed. Drum rolls. Grrr. Whoa, something is wrong somewhere. Okay, let's go. Let's go and debug. What could make this? What could have caused this?
Uh,
And what?
increments of index input
Did
put s, I think.
did I not do that? Whoa! Wow! Are you serious? So I could make this kind of mistake. Ah, okay. So this guy needs to increment. No, I think the return value should count first before it increments, so that it it will not miss any return value. So it should be the last instruction here. Hey, who me? All right. So plus plus. Here we go. Let's go back and now compile our file again. Hey, clear. Don't make my screen look buggy. Compiled with the error. Let's run it. Wow. Top man body case. Something is wrong. So someone should tell us what is wrong. We express it in there in part 2 as well. It's adding S to top man body case. That means it is still printing the S that followed the percentage sign.
In my printf, we don't add the value to other values. No,
Okay.
because
Uh,
the R value we just add it at the end.
all right. So what she's saying, if I got her right, is that we should increment. We should not ask this guy to increment and not count.
No,
H,
the return of put s, we should add it to R value.
the return of put S. Okay. That makes sense. So the return of put. So does it really? Yes. Yes. I've not even talked about it. It's 1226. So we need to add a return to this place. And how do we do that? We'll say let me save the return value inside the variable called arval. And now the code, I'm trying to store the return value of the string of this function that we declare that's helping us iterate through this string and printing each members or each character in it. We're trying to store the return value, so we take it, and give it to the main printf, so it will count it and add it to each number. That's one. And then we're trying to increment this index h, because h is our index here, right? That we're using to loop through the format, the constant character format, and the constant string format. Yeah. So we are trying to increment it so that it will not print this s after treating s like a special character, like a converter or conversion handler. Okay, those are two things. And then next thing we want to do now is to say, okay, let's add to the main return value what we have in Ava. Okay, so how do we stop this from not adding this one? So that one. What do you think? But let's find out what happened now first. Let's find out what happens now. Okay, so let's compile again. What happened? Oh, I used colon rather than semicolon. All right, no issue again. Let's run the code again. Now, see what I'm talking about. It has printed it very well. Not print the S again. So top man Podike is a man. Top man Podike is a man. But now it is running extra one, and it's running the extra one because after doing this, it comes here and still adds 1 again to the same R value. So there are several things you could do. I mean, there are several efficient things you could do to stop that from happening. So that there's now that we know that you still go and collect 1 from here, I think I'll just come here and say, let's do this. That's how you do that. Now, you may not want to do this in the way I did it. You may have another way of doing it. But me, rather than going to put R value inside this if individual if blocks, I think I want to have 1 R value work for all the ifs. Right? So I'll just take that 1 off from here, knowing that it will still come and take the 1 from here. Let me deny it of that 1. Let it come and take the 1 from here. Okay, after this is not a loop, it's a conditional statement. If it was a loop, then this would have been funny. Just an if statement. Yes, executes this code just once, except it finds the condition again. So once at a time. Okay, let's see whether this has worked. Okay, I'll compile again, and I'll run it again. Okay, so we are cool. My printf is emulating printf and is working like it. Whoa! The next thing we want to implement is what we did in this test file here. And test C, where we had to, in like 15, where we had to make the percentage specifier double before percentage printed. So I mean, you couldn't do this. You want to print 100%. You're not going to print 100%. You can do this in print, it will work, but you can't do it in printf. It won't work. You have to make it double. So we already know that our own printf now, this thing will not work as well. It will not show. It will not print this percentage. This guy here. In fact, it will even not throw up any error. It will just not print it. It will skip it. Yeah. But then it's simple. It's quite simple, right? Anyone wants to help? Anyone that is not hard? Let me check the names. Let me make mistake in pronouncing it. I know the name begins with a H, and I know that is Z. Z in the name. Who wants to help us implement this guy now? Now we are checking for what follows Haja. Is it Haja? Yeah, it should be Haja. Haja Arab. Okay, you're muted, but I didn't hear you talk. I didn't hear you say anything. Okay, who wants to help us? I'm seeing several people in the call. Let me know that you're following. It's okay. I'll just go ahead. But confirm I'm still in the call, please. Maybe that network has not thrown me out. Thank you very much. So let's make progress. Now let's go back to the file. Come on. Let's go back to the file. I think I should simply do this. So my printf.c okay, let's go and say else. Don't need to use else. Yeah, let's just use one more else. One more else if. Else if this guy that we are looking for. I wish I would have the time to turn this to switch case instead. Sure. So if what follows, I mean h plus 1, if what is after, I mean this h now, we are what?
Not D.
V? Did you say V? D. Okay, we are not working with D now. We are trying to implement this guy.
Percentage.
Understand?
Okay.
Yeah.
Okay.
Yeah. We've not gotten to D yet. So just to make sure that everyone or almost everyone is following, especially those that are live with me now. By h, we are checking for the index of this string here. We are looping through each index. So in this first if statement, what is happening here is, in this code, it checked for t. Okay, let me begin from here. For this man, when he got to this place, it checked for m, and m was not percentage this, so he printed it. It checked for a, and a was not, he printed it. He checked for m. So what happened for the beginning was that it checked, it didn't sit up man, it saw percentage there in this line. So when it checked and saw percentage, he said, oh, what? He said it now skip and not print it. I went to if else and checked. It was not C after the percentage, so it skipped it. I went to this if else block again, because I'm talking about h plus 1 now. What is after the percentage? It skipped and went here, and it was s now. And then it took the instruction here. What did it do? It used our defined function put underscore s, on the next member on the list. On the list, we named args here. We initialize a list in line 6 named args. So that member, we assume that it must be either a string or a character containing a string. You understand that we can decide not to put, a variable containing a string. We can decide not to put a variable there and put the string directly, and it will still work. Argument, I did that in the part 1, right? I did something like that in the part 1 of this series. Okay, and so this is something we are doing here. We are saying, so if you check all these things and the guy h is this, and h plus 1 is not this, h plus 1 is not this, and h plus 1 is not this, and h plus 1 happen to be this, then simply do this for us. I think one line of code we do.
Yeah.
So simply print it out. So no, we're not using any of our so it's an ordinary character, so let's use our butcher. So butcher that thing for us. Do you think this will work if I say butcher format? Oh, let me just give this character. Let's save time. So print this for us if this is what follows. Print it for us, and then I think I will need to skip it as well. So let me do this so it doesn't print 3. Okay, I don't need to, because naturally it will not print percentage. Naturally it will not print percentage, so I can't go and say I don't need to skip it. So this should work. Yeah, it should work. No, it already has instruction not to print anything percentage. So we cannot even say, if I have done format h, if I have done something like this, it should give a problem to say print format h. Maybe it might work. Maybe you want to try it and see whether it will work, but I want to skip that for now. Maybe it might work, because I'm thinking we've already given an instruction up there. Hey, don't print this guy. Don't print this guy. So let's not contradict things, but if you want to try it, it just might work. So print this, and that's it. And then, of course, our value should increment by 1 after you do that. And then let's go and try it now. Let's go back to our main.c file. Here I want to add this to this guy. Robman is Topman did percentage s did 100%. Okay, did percentage c good job. And of course that does not need any further any more argument, any Yeah. So I'll do the same thing here. Let's see percentage S did percentage C 100% good job. All right, so what are we expecting this thing to print? We're expecting it to print top man when it gets to percentage S and say did, and then print A when it gets to percentage C, a 100% good job. I don't know whether this is a good grammar or good English, but we're testing our code. Okay, it compiled with that error. Clear my screen. I want to run it. So it says top man did 100% good job. Return value 38. Top man did 100% good job. Return value 39. So what do we do now? What do we do now? Because that pucher is naturally returning something to this function. So it's now 38. How do we stop this? Who knows a more efficient way of stopping this thing right now? I mean, considering the nature of our code. Because this puts here in line 27 already returns an integer, returns 1. And it has successfully returned 1 to this function and then came here again and incremented again by 1. No, what really happened? No, what really happened? What really happened? What really happened? What really happened? Was that what happened? Come on, somebody talk. Okay, let me check it out. What really happened? Why did he return? Why is he returning 38 instead of 31, 37? What do you think?
He entered 2 times. We should add the increment of H.
I didn't get that.
In if else if we should add H plus plus to go to the next character after percentage.
Oh, H plus plus.
Yes.
I think that was the issue. I was wondering how. Thank you. I was wondering, because I didn't study return value anywhere. How is it now? So we need to skip it. Okay, we want to skip that particular. But I think I still don't. I still don't. I'm still trying to see exactly why. Exactly why. Could this be the reason? Let's find out. All right, so that's actually it. Thank you. Thank you so much. Thank you. So our printf is working. And now let's implement percentage %d and percentage %i. I think this is an opportunity to answer that question that people have always asked me. What is the difference between percentage %d and percentage %i? I mean, each time they ask me that question, I just say, well, there's actually some difference that looks minute, but significant, but just take it as though they are the same. Both are printing numbers. The other one printing integers, the other one printing decimals, but they do the same thing. Things like that. But then I think I want to expose some difference between them. Now, let me go back to my test file and do some things. So I will do this test.c. Oh no, that's what I want. What's happening? Have I lost my file? Test.c, yes, test.c. I don't know what's happening right now. I don't have my test.c.
He's inside test.
But it should be in the buffer. This is in Max. It should be in one of these buffers, yeah. And I'm seeing plenty of them. I'm seeing plenty of them right now. And I'm wondering why. Okay. So let me just navigate to test then. Let's just see. Alright, so let's do some things. Let's try to work with these guys called um 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 percentage D and percentage I. I think I want to do this. Let me rather leave this file and go here so that I don't make too much alteration, so that you will still have the things we did here retained. So I will call this, I will name this zero test. Sorry, move test to C and call it zero test to C. For that, I want to compile it again and produce an executable with the same name to avoid confusion. What's that? Oh, I did not add a hyphen O. Hyphen O. What is your problem? Header.h. What are you doing here? Oh, let's go back to our test.c. Zero test.c. Okay, header.h. Sorry, shouldn't be here. Okay, now compile again. We are good. So I want to remove this other executable file. So I want to create from zero test.c one test.c, and there I want to use that one to test, to show it, just play with it and find out some difference between percentage D and percentage I. Okay, so I'm going to move into one test.c, and I'm going to take all the things we don't need. We're working with integers right now, so all of these are not needed. So meta q. So let's declare some variable. Let's say this one is for percentage D. Let's say I'll call it try D and try I. So I want to use a, let's say, let me use puts and say compare comparing. I say compare percentage D and percentage I. Is that correct English? Compare this and this. Compare this to this. Which one is correct, please? Somebody help me. Nobody's talking over.
Anyone can go now.
Enter a number. This is printf. I use printf because I don't want a new line. Enter a number, and of course I want to use scanf to take the number. Scanf is really the man that makes these guys to behave differently. It's really the man. So we want to know what you're up to. I mean, trying to implement percentage D. What's it called now? Conversion handler. Both of them. What is expected of us? What is expected of us? All right. So here now in the first one, I'll say take, since it's for that one is for percentage D. I'll also take get us scan percentage D, scan in this particular format, and store it in the variable try D. Okay, and I want to have the same thing for us. I want to have the same thing again repeated. So I'm going to copy this, paste it here. But this time I'll say enter the number again. Enter the same number. Enter the same number. And I want to copy this. So say, wow, Emacs is beautiful. All these short stuff like this. Aisha will ever leave him in this life. Percentage I. So you should save it and try I. And then let's have some printf statement down here. So I get this. Paste it here. I will say percentage D prints this. Let me call it percentage D. You know why I did two double percentage D, right? You should know why I did that. I started to join late. But yeah, if you're seeing the video, you know why I did that. If you're in this live section, you probably want to see the video again if you don't know why I did that. Or pay attention.
And the arguments.
Oh, thank you very much. I'll do that. So percentage I prints percentage I no, yeah, take this off. Okay. I think I want to have a new line here. New line character, close the string. The argument should be try underscore I. Where is that double quote coming from? Okay, I was wondering already. So new line character and that argument and pass the argument of the variable. All right, I'm making progress. So let's see what this will do for us. I'm going to compile test one test, and of course I want the executable to be named after the file just to make sure that these things are orderly. And you know what is adding.exe, right? This is Windows that I'm using, that's why it's adding.exe. Windows will add.exe. Even when you rename it, it will be adding that asterisk, that star here to the file to indicate that it's executable. So let's go. Bang, bang, bang. It says compare. I think I should have my screen cleared. Oh, scroll down. Let me take this up. And when it's you see everything. Compare this and this. Enter a number 2. Percentage D prints 2. Percentage I prints 2. All right. Let's try this again. Watch this. Enter a number. Let me say 02. Enter a number 02. Percentage D prints 2. Percentage I prints 2. So does this mean these guys are doing exactly the same thing? Let's not do this. Enter a number. Let's say let me enter 010, right? And then enter it to 010. Percentage D now prints 10 and percentage I prints 8. What happened here? No, what just happened? I think I need a whiteboard at this point. So I'm going to share a whiteboard with you. Let me get one from the drive. I think I have nice ones already. Okay. Okay. So we are comparing. Percentage D and percentage I. See, it's fun. Oh. See, it's so much fun. See, it's fun indeed. Some things that Python and other languages just be. And you know what is happening. They'll just handle some things for you. See, you have to know what is happening under the hood, to be a good C programmer. All right, so let's compare the both of them back to that result we got there. Where is it? Yeah. So what did this guy print 8 and what did this guy print 10? I'll give you the simple answer. Percentage D is printing, let me say it prints decimals. decimal value. It's printing in base 10. Let me just percentage D is printing in base 10, which of course is what we call decimal value. Now it's not really it's not as much about the printing as it is about the scanning. So it is not much as much. It's not a STD out thing. It's an STD in thing. It's an STD in thing. Well, let me do this. What if I go and say and turn this to percentage D as well? Let's confirm whether that's true. Turn this to percentage D as well and save it and recompile that code, because this will prove whether I'm correct. So I'll go again, GCC one test C, and rename it to be one test. I like trying new things. So one test, run 010, enter 010, enter. So it was an STD in thing. It was not an STD out thing. Because right now I've changed this code to percentage D. If it is this percentage I that's making it print like that, why is it not now printing the same thing with the first one? You see, why is it not now printing the same first one? So that means the correct statement here should be percentage D scanned the integer as, and then percentage I scanned the integer as. Now you're having some fun, man. I should be correct. So let's compile again and run it again and put the same value again. So percentage scan the integer as 10 and percentage I scan the integer as 8. Now why is that 8 there? How much time do I even have? Let me see. Excuse me. Whoa. Okay, let me leave my burden. I think I want to write a code that will help us explain this better. I wanted to do some things because there might be people here who don't understand conversion of number base. If you understand conversion of number base, try converting it to a number in base in base 8. What I mean is okay, this one is simple. It's simple. Now let's do it. It's simple. So percentage I percentage I, let me finish what I'm doing here. Percentage I actually scanned in base 8, and that's what we call octadecimal. Now am I saying that percentage I scans in base 8? No, I'm saying that percentage I has the capacity to recognize other bases that are not decimal values. For example, let's try something. You know that in hexadecimal we have 1 2 3 4 5 6 7 8 9 and then A B C D E F, right? So let's try giving this guy hexadecimal value. Let's say 0xa, right? And enter the next one again. It has even refused to attend to me. Why now? Why are you behaving like this? Give me some chance now. Okay. Let me not do it like this. Let's say 0x. The 0x10 will mean 16 because f will be 15. So let's do 0x10. Why? I think I should. So I think I'll fix this code such that scan. This one should take first. I bring this one down. This guy is the D is quarreling with it. It's not allowing it to continue again. So let me cut it and bring it down to somewhere. I guess you better calm down and fix yourself. So cutting this as well. I'm gonna have it here. And for readability, let me keep a space here and take off all the spaces. So let's go for percentage I first, then percentage D, and then these printf statements have to take the same order. I just want the code to be very orderly. What's this for? All right. So because percentage D does not want to have anything to do with that hexadecimal value, it's not even allowing the code to run to the other line again. I believe that's what's happening. Let's try and see whether it will run better now. So let me compile again. GCC one test. Let's see. I want it saved, of course, as one outputted as into one test. Let's run the file again. So let's see what I do. Allow me to take this now. So 0xa, great, it's still running. See, because percentage I has, I said welcome. I know you. Let's work together. So 0xa to this guy. So you see that guy percentage I was able to recognize that, hey, you are a hexadecimal value. You are in base 16. That's correct, right? You're in base 16. I know you. And then they converted it to the decimal value. That was what they did up here. When he saw 010, he said, I know you. You know, you are in base 8. He converted it to the decimal value. And 10 in base 8 is 8 in base 10. Don't worry if this is sounding somehow. Just relax. Relax. Let me make sure my code is well arranged and beautiful. So I want to change this part to percentage I, since percentage I is coming first now. I'll change it to percentage D. Yes. You're making progress. Let me go back to my whiteboard and complete something. Time is fast spent. Fast spent. I really wish that this would be okay. Let me see how far I go. So let me cut this and take it up here. All right. Now let's do a small number conversion of number base. Let's convert 8 to number in base 10. To number in base. Let's convert 8 to number in base 8. Right? To convert 8 to number in base 8, what you need to do is, maybe I should use my pen. Pardon my handwriting. I'm not using the pen right now. Actually, I'm using my mouse. So we draw a line like this, right? And we draw a line like this. And we have 8. It is 8 we want to convert to a number in base 8. So to convert it to a number in base 8, we have to divide it by 8. Right? So 8 divided by 8 will give us 1. Remember 0. And now 1 divided by 8, of course, will give us 0. Remember 1. So 0 arrow 1. And this is 0 arrow 0. And usually we take our result from down upwards. Right? And this will be the answer will be 10. 10. So when scanf is working on that your input, on that your std in, once you put 0 before a number, it will assume that you are is octadecimal. And once you put 0x before a number, it will assume that it is hexadecimal. It will assume. So it will perform the conversion. Percentage I will tolerate it, perform the conversion and convert it to number in base 10 to decimal and print it. Meanwhile, this other guy does not have time for such. Is either taking it the way it is. It's not ready to do any conversion. So if it is 0, 1, 0, 10, it will call it it is regarded 0, just the way a base 10 number will do. Disregard it. And of course, what I put was 0. I just added 0 here, and you know that in maths, there is no big. There's usually this guy 0 and 4 is usually almost insignificant. 0, 0, 0, 0, 0, 4 is equal to 4. And so if I have a number like this, let's say 0, 0, 0, 0, 4, it's the same thing as 4. 0 is just occupying some space there. That was what happened. So if I decide to convert back, let's convert 10 now. Let's say we have a number 10 in base 8. Let's convert it to a number in base 8. It will look like this. This is how we do it. If this is 10 and it's in base 8, if you don't like mathematics, please forgive me. I will soon pass this place. It's in base 8, and then So you now have one. All this is something is necessary. Let's leave this aside. But now you've caught it. You've got it that this percentage I is handling some conversions, is tolerating numbers in different bases, right? Let me create another file called 232 test.c. I want you to write a program that will print this all these values. So 2 test.c. I'm moving to it. And what I'm going to do here is I'm going to use a for loop to print, let's say int loop. I want to take all of this off. I need at least one printf statement. Okay, so let me say for loop equals 0, while loop is less than loop is less than, let me use 20. Yeah, so keep incrementing loop.
Less than.
Thank you. Thank you. Live debuggers, man. Debugging live faster than VS Code. So what I wanted to do is just, okay, let me have this printf statement in it. I think I have to do only one thing, and that's fine. So I just wanted to print. Okay, let me use put here. I want to know. I want to establish different relationship between percentage d. I'll use tab. Backward slash t is for tab. Add the tab. Percentage d. Percentage. What now? I. How they print? Okay, I think I want to put. Let me work with this guy. So percentage o is for octa. Octadecimal. Percentage o. I put a tab again and say percentage x is for hexadecimal. Percentage x. In fact, also have percentage x. So let me put it here, percentage percentage I at the end. You just see that percentage I and percentage d will be doing exactly the same thing inside printf. Inside printf, but there's something interesting about what they are doing that you need to understand, so that as you're implementing this percentage d, you just know that you just know you have to make it work. You have to make it happen. Okay. So print this, and then I want you to. I think I want to reduce the name of this guy before I start typing loop everywhere. Let me call it n, because I have to have plenty of argument in that printf statement. Let me turn it to n for simplicity and for ease. You understand that I'm trying to loop through 0 to 20. I'm trying to print out 0 to 20 using different format specifiers. And so let's go. I will take this off. Okay, yeah, so I'll now do the same thing that I have up there, percentage d tab. Let me just copy it. Just know that, but the one up is just a string, just an ordinary string. While the one down now is some value. Or I think is it alternate method w? Okay. Put it here. cy, and how many of them are there? 1, 2, 3, 4, 5. So I put n 5 times. Okay. Of course, I want it to end with new line. So that put is going to be something that looks like a header. The other ones will follow. I think we are good we are good with this. We're good to go. So let me save this and compile. There's no error. Our code should run well. So GCC two tests. Let's see and give us an output and name two tests. Not exe. All right, let's run it. Interesting, very interesting. What observe that percentage D printed exactly the same thing with percentage I. Okay, I think I want to make it get to 20. So let me put less than or equal to 20. Let me recompile it. And then clear my screen and run it again. All right. So percentage D and percentage I printed exactly the same thing. Exactly the same thing. You can see that in Printf they are doing exactly the same thing, but there's something you need to take note of. I will do that. I will demonstrate that after now. Now, here take note of this. The octodecimal value, it has a scatter of how do I this thing at the rough drawing explain this thing as I'm talking to a primary school pupil. It's like it's quarreling with number 8. It starts at 7. Does not take it into cognizance. Remember that when a number is in a particular base, the highest possible number is that number is n minus 1. If the number is n, what I'm saying is, since this number is in base 8, the highest possible number is 7. 8 cannot be here. Since this number is in base 10, the highest possible number is 9. Possible single number is 9. This number is in base 16, so I mean, it cannot have 9 as the highest single number. It should have up to 15 as the highest single number. And it cannot have 10. 10 is not a single number. 10 is 2 digits. Right? So if A is 9 is 10. B, C, D. This F is the 15. It now begins to combine it now begins the 2 digits journey where you have 1 0 1 1 1 2 1 3 1 4 until it gets to 1A 1 until it gets to 1F. It now begins again 2 0 2 1 2 this 2 that. So this one gets to 7 and then begins the next set of digits, 2 digits, 1 0 1 1 1 2 until it gets to 1 7 again. You can see there's something like 1 8. It goes to 2 2 0 2 1 2 2 that way. So this other uppercase X just prints the same hexadecimal but in uppercase. Right? Now, percentage I is able to see these guys and know who is who and convert it to decimal and give it and store it in the variable when you're using scanf. But then, how does that concern Printf? Well, in Printf, they are doing exactly the same thing. That's what, if I'm wrong, I stand to be corrected. For what I've seen so far, they're doing exactly the same thing. But there are things you should take note of. These guys still have the capacity to convert numbers that are in base 8 to decimal, or that are in base 16 to base 10 to decimals too. What do I mean by that? Let me do another test file here. I'll call this one 4 tests. So let me copy what I have in one test again. One test of C into a file name. Is it for okay 3 tests? We've not done 3 yet. So it should be 3 tests. And I'm going to move into the file, the editor. Please as C. In case you get this code to run them and they are not behaving well, just delete the executable and recompile the one that the compilable. So let me declare one variable here of type int. I'll call it n, unless a number is a number. Well, let's say it's an integer. Okay, let me leave it here. And then what I want to do is only I think this is where I want to say print I prints this and percentage D prints this, and of course we're working with another variable now called integer. By the time we're done with this printf, we'll not be using, we'll have nothing to do with stdio.h. That's quite interesting, very interesting. We don't need we don't need these lines of code again, do we? No, we don't need them. So let me take them off. So meta kill, remove this line and remove this line. Okay, we are good, right? So we need to now put a value inside. If I put this value, you know what will happen? That both of them will print at a 4. You already know. Now, what will happen if I put a number in decimal um in octadecimal? What will happen? Watch this. Let's compile the file. Is it two or three? Three tests, yeah, three tests, and have the executable named as three tests. Yes, he compiled the error. Let's run it. Interesting. So both of them right now, what decimal would have overlooked, what percentage D would have overlooked when it is scanning in, when it is taken from the standard input, it did not overlook it when it is printing out standard output. So, and our focus is standard output. We are not doing scanf, we are doing printf, we are emulating printf. But this guy is converting octadecimal value to decimal value, both of them. So now it's no more stress. It's no more stress for us. So you don't need to be scared. What do I do to print I? What do I do to print f? Print d. Sorry. What do I do to percentage I? What do I do to percentage d? Whatever you do to percent, you can just put the both conditions here. Let both of them work. So far, that's what I know about them. Now let's see what happens if we give it a decimal value. I say 0xa. 0xa is supposed to be 10. Look, as you can see from this thing. Let me just go down a bit. This is the percentage s printed decimal value, and this is the decimal value. This is where we have 10. So where we have 10, the equivalent of 10 is a here. In fact, let me take it from this way. We have, by the right, we also have decimal value. So 10 is a. So 0x is supposed to give us 10. If I need to go inside now. Okay, I just saved it. Let me now run it. So 10, 10. We've converted it. So how do we now implement this? I will implement it, and this section will end. We have short time left, but let me connect my system to a power source. Confirm again that you've been hearing me. I've not been talking alone.
Yes, well.
Yes, we
Thank
get
you.
it.
Thank you. Does anyone have any questions before I continue? If you have any question, please ask. So I'll be. All right, I'm back. All right, let's make progress. So now, how do we make? I don't think we can do this in 30 minutes. We have to take extra time. This is well. I have another section. Okay. Okay. Let's make progress. We have to go back. We have to have uh, um, um, another function that will handle this for us. All right. So I'm leaving this place now. This is our test directory. I'm leaving it. I'm going back to the root directory where we're inside part3 directory. And interestingly, okay, let's just add any function. So I will go back here as well and name the function put int. Or say print int. Let me say put int. Print it is fine. Put int. Let's see. Okay. Let me. I like to be fast, so let me copy the content of which one is closer to it.
Put S.
Okay. Okay, put S into put in the C. Alright, let's roll. So put in the C. Yes. Great. So let me take this off from here. Aha, I think I have to go out to the test. Wow, this is man. I always knew that 2 hours would be such a short time. This I always knew, but I want to cover much. I want to cover as much as I can cover. So part of it is taking longer. It's worth it, right? It's worth it. I think it's worth it. I have another session in about an hour from now, but let's see how far we go. I wanted to go and rest a bit and do some things, freshen up, recharge my stomach and rest. It's not easy. It's not easy. Alex, it's not. When they say hard things, they're not joking. They're not joking, but they are all possible. You can see they are possible. I came in totally blank, a newbie, nothing, no zero knowledge of programming, and I'm here today. So as hard as they can be simplified. They're very possible. So I'm deleting this and taking this off. Oh, did I just take on value? Okay, no problem. Fine. Uh, welcome. So what? Yeah, we still need this I value. Still need, because want to still return something. Return int. And I want to change this to put int name of our thing, and then the argument has to be type int. So any number, let's say integer. I'm going to take us back to our test directory and do some tests and then come back to show what I want to do, what I want to implement. And I think I will need the whiteboard to demonstrate this as well. Okay, and there has to be a return value, of course, and that will be of type int. So we're not sure what we're returning for now. We're returning the alpha, so we are sure we're returning alpha, and here we go. Okay, let me quickly go and put this in my header file as a prototype. So that it doesn't escape my memory. So header.h, welcome your new member, and then semicolon. We're good. Back to where we were. Well, I will come back to this place shortly. Let me go and create some more test file and demonstrate something about putcar that we have all done, and most of us don't know. I did this and I didn't know why I was doing it. I did it, it worked. I didn't know I was doing it until later on. That's how it is in ALX. Sometimes you understand some things when you're past that level. That is if you keep pushing, if you stop. If you overcome the feeling to give up, if you overcome the feeling to if you keep yourself motivated and have the right mindset, develop the right attitude, man, you will make it. You can do it. It's hard for everybody, even the ones who are programmers already before they came in. It's hard for them. I know someone who came in a full stack software engineer. It's hard for him. That's right. No, but I'll keep pushing. Now we are in the test directory again. So we are creating our test number 4, right? So let me copy this file. I don't know which one is closer now. I think 0 is closer. Let me copy the content of the file. 0.c into a file name for test.c. Okay. Please confirm our environment is not very noisy for you. Too noisy for you. I hope my voice is loud enough and clear.
Yes, stop, man. Yes, stop, man. Your voice is loud and clear.
Thank you very much. So, what I want to do here, I want to show you, I want us to play with Puka again. Let's play with Puka again. Now, meta kill all of them. Let's use Puka. Now, if I want to put car you're already aware that Putka can Putka any character that wants the channel output. You're already aware that if I declare a variable of type, let's say um, uh, animal of type, please ready development of that television. Okay. And I say is equal to, of course, is a string. Let me not confuse anybody, please. But there's something that looks strange. And I look strange to some of us. So let's just do it like this. The one we know is a string, and it's goats. So having that string. You are aware as well that if I come here, I want the later goats. That since goats is at index 0, I can say put card, can give put card the name of the variable and say put card go to the elements at the first index of the variable animal, you know, and print just print out the elements at the first index of this variable. You know that this will work. I believe you know. You also know that I could loop through these things. I did that earlier. I could loop through it and print out everything that is there. I haven't known that. Now, what about excuse me. Excuse me. Guys, Nigeria has happened to us. They just seize the power. And let me believe that our system will, let's see how far my system will take us. Let's seize power. All right. So now let's do some things. What about printing number with Putka? What will happen when we print number with Putka? Now, watch this. I want to take all of this off and you try to use number to print. Let's say I want to print 65. 65. Now, a lot of us, most of us, if not all of us, are familiar with the fact that Putka will rather go and print the character or whatever it is that 65 represents as an ASCII value or a SI value, whatever you call it, ASCII, right? So let's now compile our file, for test file, for test.c, and let's see, no error. So I go, it prints uppercase A. Now it's adding a new line by default. This is Windows. Windows add a new line. It's not my window. It's adding a new line for us. I didn't add a new line. It's not supposed to have a new line. So do where to, if you're doing this, do where to have another Putka that is printing a new line after it. Okay, it's a good habit. Now, it printed A, but what if I want to print number of Putka? Watch this trick that you must have done. If you are this level, if you are
character 0.
Thank you, character 0. Now, if I add this character 0, what it does is, let me compile again. It now prints Q. Now, why didn't it now print the number when you're using character 0? It now printed Q. Now, the person that said character 0, I guess you've used it before to print numbers from 1 to 9, from 0 to 9, rather,
Yes.
and it worked.
Yes.
So, why is it now printing Q instead of 65? Want to tell us? I should go ahead. Okay, let me go ahead. Now, if I had done this with 0, watch. If I had done this with 0 and come here and say and compile and run this file, it prints 0. If I had done this with, let's say, 9 and save and come here and run this and run it, it prints 9. Let me show you what is happening, exactly what is happening. This guy is concatenating these two characters. It's concatenating them and turning them into an SI value and then printing the SI value. What is the value of 0? The value of 0 is 48. So, and this line is adding 48 to 9. So you just did 9 plus 48. And 9 plus 48 will give you, what number is that? 57, right? 57. And that 57 is the SI value for this 9. Let's check the table and confirm that I'm right. I have one table here. So let me minimize all of this. Where's that guy? Better commas. Don't waste my time. My battery is not smiling right now. Where did I put that guy? Did I put that guy? Did I put that guy? Should be here. Yeah. Here. Here. No. That man. My documents. Software engineering. Resource materials. I'm not sure where it is again. Yeah. Conversion charts. All right. Come on, open fast. You're not using internet now. Open now. How do I zoom in? Right now, I'm under pressure. I need to be fast. Who knows how to zoom in this app now? Okay, Control Plus works. Now, watch very well. 57 was what we arrived at, right? And this is 57. 57 is 9. You can see it. 57 is 9. So when we are saying plus the character 0, we are saying plus 48. We are saying 9 plus 48. That's what you're saying. So that 9 is not seeing this 9 that is here. What does this mean? Where is it? 48. Look at 0. 0 is 48 in decimal. So it saw that decimal value 9 and added 48 to it, and it came to 49. That was how I printed 9. When we added 0, it saw the decimal value 0 and added 48 to it, which is the decimal value of this character. And 48 plus 0 will give us 48. And 48 here is 0. When you put 1, it will see 1 here. It will add 48 to 1, and that will become 49. And 49 here is the decimal value for 1. That's the trick we give it to make it print 1 to 9. Having known that, let's make progress. Let's see how far this battery will carry us. Take us. Man, this is becoming now, and I believe that my battery does not really last as long as it should last for. Again, because I charged my system very, very preparing for this class. Charged it very well and kept it. Okay, let's go back to our codes. This is Emacs should be here and the other guy. All right. Now, having known that, let's now leave this directory and come back to our root directory. What file was that we were working on? I was trying to create a new function, put int, right? Yeah, put int. Let's see. Let's come back to this test. I want to show something again. Because we don't just want to implement something that will go and pick an int and print. We want to be able to take care of if the int has different digits, because if you just do it the way we did %C, it will go and print number. I think I should just end here. We'll continue in the next section. What do you think? I think I should just end here. But basically, the point where I am now, what I'm trying to drive us to now is where we don't just write a function. We don't just implement a %d that will print the number 4. What if in that %d or %I, the number that is printing is like this? We need to loop through something like we need to be able to access each members of these things and print them out. And what if the number that you gave it, of course, %d is the same as %I. Now we're doing the same thing. What if the number is a negative value? We need to be able to handle this as well. So that's what we want to achieve, and it will continue. This is the Printf series. I think we are good to go on part part 3. See you in part 4. Any questions at this point?
No, it's clear. Thank you.
Yeah, it's clear for you, right? Others,
Yes.
let's hear from others. Yeah. So I'll announce the next meeting. Okay, we meet and we'll continue. Don't worry, we'll decipher these things. We'll make our things simple. We'll grind it into powder. Grind it into powder. Make it simple. So I won't touch these codes again. There are saved. What did I do here? Okay, I won't touch the codes. I think I should delete print int, put int from here. Yeah, because we didn't do anything there. So delete put int. Let me exit my editor. What is not saved now? Okay, go. I don't want again. All right. So we'll not really implement put in. So let me exit it, or let me just make it empty. No, remove it. I'm removing it. Put int. Okay. And this is what we've done so far, and we've tested our code so far. So that it's able to emulate printf to the extent as in we are done with putcar. If we give this into the checker, I think every kind of case, no matter the edge case, it will work well. No matter the character you give it, it will print it. And our putcar here should be able to do what normal putcar does. I mean, we should be able to trick our putcar into printing numbers as well, numbers 0 to 9. That's the way we trick the normal putcar. Yes, we should be able to do that. You want to put the code and try that on your own, play with it. And the link to the repository is here. I'm going to give it to you. So you play with the code. I've even pushed it. I'm not pushed, I'm sharing link. All right. Let me go this way and push from here. And so I go. F series part 3. Okay. So let me hear from others. How was it for you? Nobody has a question. It's very interesting, no? Very interesting that no one has a question. So this is the repository journey through C, and the directory is C printf, and of course we just dealt with. In fact, let me give you the link to the entire directory. Copy. I'm gonna post it in the in-call message. There it is. Grab it. Go play with it. Play with it. All right. So thank you all for coming. My system has gone off. My phone is still on from where I'm talking. So thank you all for joining. Thank you. I am so glad. I'm not so glad we have opportunity to convert together and do hard things and make hard things easier. And please, if you're not following us on YouTube, do where to follow. Follow us, Code Tribe. We used 2 YouTube channels. My YouTube channel and the one we use for Code Tribe. So do where to follow. And if you have suggestions